Hello everyone, welcome back to another video. Today we're going to be talking about logarithmic differentiation. It's very similar to implicit differentiation. It's just we're going to be using ln's to help us find dy dx instead of just kind of using our previous tricks from implicit differentiation. So they'll always tell you to when you have to use it. So let's just do an example and I'll show you how it works. So this would be, for example, y is equal to x times the root of x plus 1. And usually they will put this y here for you, and you'll see why. If they don't, and they put an f of x, just change it to a y. It helps out visualizing this whole thing, but if not, just do that. So the first thing to do, we want to utilize the ln right away. So we're just going to put an ln in front of the y and the x, because that's not going to change the equation. So that would be ln of y equals to the ln of x root x plus 1. And just keep in mind that this is all in ln. And next we want to use a rule of logs on the right side, where we can break up the product of two logs by adding them. So that would be the ln of y equals to the ln of x plus the ln of the root of root x plus 1. Now what we want to do is we want to rewrite this root in a different way. So let's, again, just keep this side the same, and we're going to keep this the same too. We're just going to put this as ln of x plus 1 to the 1/2 power. We can do this. It's the same thing. And we want to do this because we really want this power to be in front of the log, and we don't really want a power in the log right now. So to do that, we'll say it's ln of y equals to the ln of x. We're just kind of rewriting this one here. So we're going to move the 1/2 over here. So that's a 1/2 ln of x plus 1. And now it's much easier to take the derivatives of this whole thing. So the derivative of any variable with an ln is just going to be 1 over that variable. And that's just because the rule for ln's is that it's going to be u prime over u. And a y's derivative is 1, and so it's 1 over just y. So it's going to be 1 over y, and this is a dy dx because we took the derivative of a y. And then we're going to do the same thing for ln of x, so this is going to be 1 over x. And then this is the only one that's different, so we have a half, which is just a constant, so we can multiply it by it. The ln of x plus 1 is very similar. X's derivative is 1, and this is 0, so it's still going to be 1. It's just the u, though, is x plus 1 instead of just x. Now before we do some final stuff, we want to make sure that we can put this 1/2 attached to this one just to make it cleaner. So if we just actually multiply it, this would just be 1 times 2 times x plus 1. So same thing, we're just making it a little cleaner. Then what we do when we get to this point, when we have everything, the derivative taking of everything, and we also have this 1 over y for the dy dx, we want to multiply by y because this will cancel with the 1 over y and have the dy dx alone. So basically what we've been doing already. So dy over dx equals to, we really just want to do the same thing to both sides. So if we multiply by a y here, we have to multiply by a y here as well. So this is y multiplied by just everything's the same. So 1 over x plus 1 over 2 times x plus 1. Okay? And the last thing you want to do is, because we have a y here, we actually know what y equals, though. So we at the very top, it said y is equal to this here. So your final step, usually in these problems, is actually going to be plugging in whatever y equals to this y here. So in this case, it's x root x plus 1. So it's x by x root x plus 1. And this is still multiplied by everything else. So 1 over x plus 1 over 2 times x plus 1. And then that's your answer. So your dy dx is usually going to equal this kind of larger term, but this is all you have to do. Now I want to do a couple more examples so you can get the process down, because it's really not too bad once you do it a couple times. So let's say we had a kind of an interesting one. We had y is equal to x to the x power. So this is weird because usually we know what happens when we have x to some number. That's the power rule. We know when the base is a number and there's x on top, then it's an exponential rule. But we don't really know what to do when there's an x and an x. Well, it turns out the best way to solve this is logarithmic differentiation. So we're going to do the same thing. We're going to put an ln to both sides. So this is ln of y equals to the ln of x to the x. Our next step is kind of like this one right here. Whenever we have a power, we're going to bring that power down because of that rule for logs. So it's the ln of y equals to x ln of x. Once the power is gone, kind of like here, we can take the derivative of all of these functions. So just like before, the ln of y, that's just going to be the 1 over the y, and then the dy over dx. And then that's going to be equal to this one right here. So to take the derivative of this, though, this is a product rule question. This is an f and this is a g. So let's just use the product rule. So the first function's derivative is going to be 1. And then we're just going to carry over the second function, the ln of x. Then we're going to add the second function's derivative. So that would be 1 over x. And then we're going to use the carry over the first function. So that's just going to be x, and for the case of simplification, like x over 1. So now let's simplify and see what we got. So this is 1 over y dy dx. Again, we're just kind of carrying it over. 1 times ln of x is the ln of x. And because this will turn into, if we multiply, to x over x, this just kind of simplifies to just 1. So it actually is just 1 here for this one. And now that we've simplified it, we can get rid of this dy dx just like before. So we would multiply by a y, then we'd multiply by a y, so the entire thing, just like before. We get that dy dx has some expression multiplied by y, so y multiplied by the ln of x plus 1. And now we have this y here, and just like before, we can plug in what y equal to from the start, which is x to the x power. So dy over dx equals to x to the x power multiplied by the ln of x plus 1. So as you can see, the process is very similar for them. Sometimes you have to utilize other rules, but pretty similar. I'm going to come back with one other example just to see if you really got the hang of it. Okay, so we're back for one other example. I want to try something that's pretty similar to the last one. So what if we had something like y is equal to x to the sine of x? So again, we have two x's kind of together, so there's an x and an x. Even if it's not quite the same, if they ask you to use logarithmic differentiation, you can do it just the same. So they do something like this, kind of similar to the last one. So if we had the ln of y equals to the ln x to the sine of x, we're just going to bring down this exponent. So the exponent happens to be a trig function, but it doesn't really matter what it is. So the ln of y equals to the sine of x multiplied by the ln of x. And now this, again, is a product rule, so we can take the derivative of both of these with the product rule. So this would be, of course, 1 over y, and this dy dx, just like prior. And taking the product rule, we do the first one's derivative, so that would be the cosine of x. We bring over the second one, so that's ln of x. Then we add the first one just as it is, so that would be sine of x. And then we multiply by the second one's derivative, so that would be just 1 over x. After we do that, we just want to simplify and do the kind of a similar process as before. So that would be 1 over y dy dx equals to, this one really just turns into the ln of x times the cosine of x. And in this case, we can leave this as it, but it's going to be helpful later to put this as sine of x, because this is like sine of x over 1, over just an x, just to make it cleaner. Now that we have it simplified, we can help and solve for this dy dx, so we're just going to multiply by a y, then we're going to multiply the right by a y as well. So that's dy over dx equals to the y times the ln of x times the cosine of x plus the sine of x over x. And just like before, we are just going to, whatever y equaled from the very beginning, we're just going to put that in right at the end. So it's x to the sine x in this case. So we have dy dx equals 2x to the sine of x, and that's all going to be multiplied by the ln of x times the cosine of x plus the sine of x over x. So as you can see, this would be your answer. Even though they can give you weird stuff like just a weird trig function with an x, and they ask you to solve for it, if you just follow the same process, really is just putting the ln's, applying the derivatives, applying some log rules you just probably already know, then solving for the dy dx, putting that y back in from the start, usually we'll get the answer pretty quickly. So I hope this helped with logarithmic differentiation. Thanks for watching. I really appreciate it.